We are at 6.7 and we are graphing linear inequalities in two variables. So variables x and y. Okay, so we're going to go ahead and get started. And a linear inequality in two variables such as x minus 3y is less than 6 is the result of replacing the equal sign in a linear equation. So instead of just having the equal sign, you replace it with an inequality. So you can see the different types that you can replace it. A solution of an inequality is two variables, x and y, is an ordered pair. Okay, so you can see the ordered pair, x comma y. Now that produces a true statement when the values of x and y are substituted into the inequality. Okay, so I'll read the definition and then we'll do a couple problems. You'll see it will make sense. So which ordered pair is not a solution? So you have to be careful because sometimes they ask which is or not. So here they want to know, so that means three of them are and one of them's not. The solution of x minus 3y is less than or equal to 6. So let's just go ahead because it is multiple choice and just plug in. So what they're saying here is x is 0 and y is 0. So if I just go and plug into here, 0 minus 3 times 0, I'm just plugging in here, is less than 6. So 0 minus 3 times 0 says anything times 0 is 0. So basically this whole thing becomes 0. Okay, is 6 greater than or equal to 0? It is, so it will not be A. Okay, because only one of them's not true. So the first one's true, so that's not the correct answer. So let's go ahead and plug in 6, negative 1. So you have to be careful. 6 is x and negative 1 is y. So let's go ahead and do that. 6 minus 3 times negative 1 is less than or equal to 6. So 6, so you've got minus 3 times a negative 1, so that's going to be 6 plus 3 is less than or equal to 6. 6 plus 3 is 9, is less than or equal to 6. So is 6 greater than or equal to 9? Nope. So we have found it. We don't have to go any further. So B is not a solution. So all you're doing is plugging in whatever ordered pair they give you, and make sure you plug in correctly the right one for x and the right one for y, and then you read the statement. It's either true or false. So this was the one that was not true. So let's just try one more. So here is the inequality. We have it here, negative x plus 2y is less than 8. So they've given us a few ordered pairs, 0, 0, 0, 4, 4, and 3, 5. So they want to know, tell whether the ordered pair is a solution of negative x plus 2y is less than 8. So let's try 0, 0. If I just plug in 0 plus 0, that's going to be 0 is less than 8. Is 8 greater than 0? Yes, it is. So the first one is an ordered pair. Let's see if 0, 4 is. So x is 0, negative 0, it's just going to be 0 plus 2 times 4 is less than 8. 0 plus 8 is 8. Is 8 greater than 8? No. So that is not true. All right. If it was equal to, if it had the equal sign, that would work, but 8 is not greater than 8. So let's try an x of 3 and a y of 5. So let's plug it in. So minus, then x is 3, plus 2 times the y here is 5, is less than 8. So negative 3 plus 10 is less than 8. 10 minus 3 is 7. So is 8 greater than 7? Yes. So the first one and the last one were definitely solutions. The second one was not. So you can see that the statement has to be true for it to be solution. So now we're going to go on to graphing. Okay, this is what this whole section is. 6.7. So it's graphing linear inequalities in two variables. So I have some graphing paper. Hold on, let's put it the right way. And we're going to go ahead and we're going to get started. So let me read the instructions real quick before we start. Graphing a linear inequality in two variables. Graph the boundary line. So the boundary line is either going to be a dashed line or a solid line. It is a dashed line for less than or greater, okay? Because that means it does not include, it's like the open circle. So the open circle and this inequality graphing is done by dashed lines like this. So you can see that it doesn't include the line. It will shade all the way up to the line but not include the line. And then you to get a solid line for if it's equal. So here, just a solid line like that. That's how you distinguish the difference if you're looking at a graph. Test a point not on the boundary line, because on the boundary line it doesn't help. You've got to test either above or below, and as we graph you'll see what I mean. And you check whether the ordered pair is a solution. So say I have a top of a graph and the bottom of a graph. If I test the top and I pick an ordered pair on the top of the graph and it works, then everything above that, the top of the line will work. So we do some and you'll see what I'm saying. And then you shade where it's true. So let's start with our first one here. So y is greater than 4x minus 3. So then the first thing you do is just say y equals 4x minus 3. You change it to an equal sign just to go ahead and start graphing it. But understand, so I do this so I don't forget. Because it's natural to do a solid line, I do my dash line to remind me that my line is going to be dashed. Okay, so you know from graphing, because we've been graphing, that this is slope-intercept form. So this is the y-intercept and this is the slope. So the slope is 4 and b is the y-intercept, so that point is 0, -3. Okay, so look how easy this is going to be. Once it's solved for slope-intercept form, it's fairly easy. So we're going to start at 0, -3. This is always the point that crosses this y-axis. And I'm not labeling them, I'm letting you know that I'm doing them by ones, okay? So we know if this is 0 and down 3, 0, -3 is my starting point. Then I use the fact that I have the slope, so it's considered 4/1. Remember, every number is out of 1, okay, if it's an integer. So -5 would be -5/1. So that means, remember we said rise over run, the change in y over the change of x. So rise meaning going up and down, since at +4, I go 1, 2, 3, 4 up. Then it's a +1, so I go 1 to the right. So that is my line. The minimum amount of ordered pairs to make a line is 2. So I've got 1 here and 1 here. A little bit off, I should, there, okay. So this is where I have to be careful, and this is where I did that red dash line. That reminds me not to do a solid line. So just kind of doing my line like this, and this line goes on forever. So that's what I mean by shading. I'm either going to shade this whole entire left side up into the boundary line, or I'm going to shade the whole entire right. So what they mean by picking a test point is pick a point that is not on the line, is clearly on one side or the other. So one of my favorite test points to pick, and I call it TP for test point, but I'll write it out now. One of my favorite, as long as it's not in the boundary round, is 0, 0, because it's real easy to plug in, and it's not. It's right here, okay? So what I'm going to do is test this. If this is true, then that means I shade the entire side. If it's not, if this isn't true, then none of these ordered pairs are true. Then that's going to be on the other side. So look how we're going to do it. We're going to go back to the original inequality, not the equal sign, because we won't be able to read the inequality. And the reason I like to do 0, 0, because you don't have to worry about mixing up which is x and y. So I plug a 0 in for y is greater than 4 times 0, anything times 0 is 0, minus 3. Okay, 0 is greater than 0 minus 3, which is negative 3. Is 0 greater than negative 3? Yes. Okay, so my test point is right here, and since this ordered pair right here, or this point, is true, every single point is true on that side. So real quick, I just shade the whole thing, just doing it real quick so you see. So all of this is true, and if I did it all nice, I'd shade all the way up to this dashed line, and all these numbers would be included in the solution, okay? Everything on the left side. None of these would be in the solution, because none of these would make this inequality true. Only everything on this side would. So once you test one point on one side, and that point is true, all the points are true on that side. If I test a point on a side and it's not true, then that means none of that side is true and only the other side would be true. But here this is true. So let's go ahead and graph a few more. Let's graph this one when it's not solved for y yet. So x plus 2y is less than or equal to 0. Okay, so just to go ahead and solve it, consider it just an equal sign, and I'm going to put it here. X plus 2y equals 0. So remember, we always want it to look like this. Slope-intercept form, okay? Solving for y, basically. Because if we solve it for y, then it's very easy to take the y-intercept and the slope and graph two ordered pairs, and from there decide what we're going to shade. So we know it's going to be equal, so this one's going to be a solid line, so I'm doing that. That's a natural thing to do, a solid line. So we're going to solve for y, so that means I don't need the x, so subtract the x. So then I've got 2y equals 0 minus x is just negative x, right? And then divide by 2. So y is equal to negative x over 2 is the same as saying negative 1/2 times x. Okay, they're one and the same. So that means I can go ahead and plot my points. So this is what we call a direct variation. You had learned that before in chapter 4. So we're now in chapter 6. So remember, direct variation, the y axis, it runs through 0, 0. So it can always start right here. So we know it's negative, so it should be going down. So it's down 1 and then to the right 2. So down 1 and to the right 2. And here's the other point. We know it's a solid line. So I'm going to just make it a solid line. Now obviously, since it goes through 0, 0, I cannot use that as a test point. Those are one of the times that we cannot use that as a test point. So I clearly can pick a point on this side, or clearly pick a point on this. Since I like to work with positives, let's pick something that's clearly, so 1, 2, 3, 3, 2 is clearly here, and I'm just doing it real light. That's my test point, okay? So TB, that's my test point, 3, 2. So remember, you go back to the original up here and you plug it in. So x is 3. 3 plus 2 times y is 2 is less than 0. 3 plus 2 times 2 is 4, so that's 7. Okay, is 0 greater than or equal to 7? You should see that that is definitely not true. So that means this point isn't true, nor are all of these. These are all not true. So that means all the true is at the bottom. So that's where you shade, because you're finding where your solutions are. So all these solutions are true. Everything on top is not. And also the line is part of the solution. All the points on the line. So I'm not doing a perfect job, but I'm kind of showing you here, because I don't want to get so close that you can't see the line, because it's kind of all blue. So yeah, if I want dark looking here. So all of these are solutions, nothing on the top. All right? So that's what you're doing. So it's a little bit, you've learned how to graph and solve slope-intercept form and graph. So you're just doing the same thing. The only thing you're doing now is testing and shading. So let's do 2 special lines that come up, and you just have to read them correctly. So one of them is y is greater than or equal to -3. So you've got to think about it like this: y equals -3. So remember, we've touched on this many a times. That is a horizontal line with a 0 slope, and it's just going right across in a horizontal line. So we have to go down to -1, -2, -3, and it's solid. 1, 2, 3. And we just do a straight line like this. Okay? So you don't have to test, you have to read it, because there's only one thing. Y is greater than or equal to -3. So we're either above or below. So y are the new values. If they're greater than -3, that means they're going to be on top of like -2, -1, 0, 1. So that means I shade everything above. Okay? You understand as you're reading? Y is greater than or equal. So the equal is here. Greater than -3 means the numbers are higher than -3, -2, -1, 0. So you are just, all these are solutions. Then there's also another special kind of line. So let's do the other one. It's a line x is less than -1. Okay? So again, there's not much to this. You just have to remember, so put it as an equal. So x equals -1. So it's a vertical line, and this is a dashed line. So be careful. It's dashed all the way through -1. Okay? So again, it's a matter of reading it. So how is this facing? -1 is greater than x, so it's facing this way. So that means all of this is true. These are all solutions, so you just color this side. Alright, so you're just picking a test point, or on these, which are very straightforward, you're just kind of reading it and seeing what you're going to test. Let's just do one more. Okay, just to be sure. I'm just randomly going to pick one. Okay, here's a good one, because it's got a negative in. So let's go ahead and try with this one. Okay, don't want it too much. So you can see, okay, so this is good. So here's the one I picked. 5x minus y is greater than or equal to 1. Okay, so I like this because it has a negative. So there's some things that we have to do. So let's go ahead and solve this for y. So remember, we want it to look like this. Alright, y equals mx plus b. So that means I'm going to subtract the 5x and bring it over to this side. So negative y is greater than or equal to negative 5x plus 1. I'm dividing by a negative 1, so y is flip the inequality and do 5x. Negative 5 divided by negative 1 is a positive 5, and plus 1 divided by negative 1 is minus 1. Okay, so I solved it as an inequality. I could have also put an equal sign, it would have been fine, and when I tested it I would have found the right side. So I'm going to go ahead and use the fact that the y-intercept is at negative 1, so 0, negative 1 is right here. My slope is 5, which means 5 over 1, so at 1, 2, 3, 4, 5 and over 1 gives me my other point. I also know that the inequality tells me it's a solid line, so kind of just winging it here like this. And then I want to test. I technically can test 0, 0 because it's not on the line. So I'm going to test 0, 0. If it's true, all of this is shaded. If it's false, we shade the other side. So remember, always go back to the original, what it looks like here. So 0 minus 0 is 0, right? That's why I love to test 0, because it makes it easy. Is 0 greater than or equal to 1? No, it's not. So that means none of this side is true. That means the solutions are on the right side right here. Okay? So you shade that in and you do a better job. It's nice to have some pencils, different colored pencils that you can shade. I'm just doing it real quick here with some Expo markers. But that's what it means to solve and shade linear inequalities. So we get plenty of practice on that. Okay guys, so this was the last section in chapter 6, so we'll be coming up to a test shortly, and I will see you in class, guys. God bless.